let's talk a little bit about the background.
The background.
Yeah, why are we talking about data and visualizing data and analyzing data? We are just living in a highly complex world. And what we are doing throughout the last years is we enhance complexity more and more and more. So it's even a real problem, anytime more a problem for the people to take decisions in this world. So the big question we have is it possible to reduce complexity in a way that people can decide? You know, we are living in a world which is highly unstable, which is unpredictable, which seems to be unpredictable. So what we have to do is we have to find ways to cope with this complexity. And if we look at the reduction of complexity, it is all about data. You know, when we are talking about complexity, we mean that we are living in a world where we can analyze different things, and the question is, do we understand the relations between these data? If we understand the relations, we can reduce complexity by pattern formation, and this is a big problem we are talking about.
I think this was a major point, to reduce to pattern information, because reductionism
it's not to reduce to pattern, but pattern is reduction of complexity. If you understand the pattern, you can predict. If you don't understand the pattern, you cannot predict. So, in a way, when you don't understand the pattern, a complex system is a complicated system. Without understanding the pattern, complexity is not complexity, but complicated. And a complicated system cannot be predicted. So we have to always ask ourselves whether in this complex world it's possible to detect a pattern which is able to reduce complexity. This is the major task we have. And I'm quite sure that when we are talking in the next years about decision-making processes, we will talk about pattern formation in data. This is nearly everything. And if we look at this problem now, we have two possible ways to deal with this. The first is, how can we visualize data? Because you know, our brain is the world's most famous pattern detecting machines you can think of. There's a system consisting out of millions and millions of cells interacting with each other. So we have here a system which is able and ready to create patterns in a high complex way. So what we have is, we have a system which is able to detect pattern in the outside world, because it's in itself very complex. So it fulfills Ashby's law. This system is anytime more complex than the pattern or the data we have to analyze. So we have a real good machine for this. But to make this machine work, it's necessary to present data in a way how this machine can handle it. So to visualize things, for example, is an extremely good way to get access to data. So the one possibility to reduce data by pattern formation processes is the question how to present. But this is only half of reality, or half of the possible way to do it. The other half is the question, which data do we present? And this is also crucial. So we have two ways to deal with the problem. The one way to deal with the problem is to ask for the presentation of the data, how to make it mostly fit for the human brain. And the other question we have to ask ourselves is, are there data which make it more possible to reduce complexity, because there is an additional information in the data.